In this video, we're going to talk about the intermediate value theorem. So let's take a look at what the theorem tells us, and then I'll show you an example on how to use the theorem. So the intermediate value theorem for a continuous function says, if you have a function f that is continuous on a closed interval, let's say from a to b, and if y naught is any value between the function values of a and function value of b, then this point is equal to f of c, where c belongs to the interval ab. So let's elaborate on this a little bit more. So what we're really saying is, if f of a is right here and f of b is right here, so one of them is greater than the other, then we can say there is a number c within this interval ab such that f of c is equal to this number y naught. So that's what this theorem is telling us. Very powerful theorem, but one consequence of this theorem helps us to find roots of functions. For example, if you have, let's say, a function that looks like this. So say f of a happens to be a value right here. Let's call that f of a. And then it's continuous, right? So let's draw a nice, smooth, continuous curve. Maybe something like that. And let's suppose that's f of b. So you can see that f of a happens to be less than f of b. So f of a is below the x-axis, f of a is below the x-axis, f of b is above the x-axis. In that case, we say that there is at least one root, meaning when the function will cross the x-axis. So if this happens, then we can say there's at least one root to this function on the interval a comma b. Of course, there could be more, but we're saying there's at least one c where the function will cross the x-axis. Root is another way of saying when the function is equal to 0. So let's show an example and see how to use this theorem. Here's the example I'm going to work out. So we want to explain why the equation cosine x equals x has at least one solution. All right, so we want to use the intermediate value theorem. So let's consider the function f of x is equal to simply cosine of x minus x. So I'm pretty much moving this to the other side, setting it to 0. So we have, that's our function. And we want to know if there's at least one root within some interval, any arbitrary interval. So let's pick an interval. So we're going to consider the interval 0 to pi. You can choose any interval. I'm going to choose 0 to pi for convenience. And we want to see what happened. Is there at least one place where the function will cross the x-axis? So let's evaluate the function at 0. So consider this is your a and this is your b. So f of a is going to be f of 0. That is cosine of 0 minus 0. We know cosine of 0 is 1, and 0 minus 0, that will simply be 1 minus 0. That's 1. So I know this is positive, greater than 0. Now what about f of b? Well, that's going to be f of pi. So this is cosine of pi minus pi. Well, what will that give us? Cosine of pi is -1, and minus pi, that's just a number. Whatever that number is, it's a negative number, so less than 0. So we see that f of a value is positive, f of b value is negative. So if you were to come up with a picture, so roughly sketched, let's say 0 is here, and we get a positive function value. Let's say this is up here. F of 0 is positive, and pi is right here, and we got -1 minus pi, so it's somewhere down here. Let's just say that. That's f of pi, which is less than 0. Because f is continuous, I can draw the curve however I want, a nice continuous curve. Maybe not exactly that, but maybe something like this. And I see that there is at least, could be more places like that, but let's just say that's the graph. There's at least one place the function will cross the x-axis to go to the next point. So what does this mean? Well, this means that by the intermediate value theorem, there is a c in the interval AB, so there is a number c in the interval, such that the function evaluated at c is equal to 0, meaning there is at least one root to this function, which means that cosine of x equals x has at least one solution or root, namely c in the interval a to b. All right, so that's illustrating the mean intermediate value theorem.